Good afternoon. Welcome to our lesson today. Just a minute. I will start engaging you. So, good afternoon. I hope you're fine. Now, all the way up to 4 p.m., I hope just engage with me through the chat section. I will be able to respond to you, write to me, I'll be able to talk back to you, and we are going to discuss the small part that is remaining on the part of the measurement, which is density. Actually, I started density at that point. I want us to finalize the density term is that force. So, if you want to watch all the other videos from the beginning of the physics for 1 up to now, just go back to our channel, that is Ambassador Foundation Learning Channel. I dare you go through it, you will never regret. So, I have a pleasure. Welcome to our lesson. So as you're watching me, you can write on the chat section, you can write where you're watching me from, tell me where you're watching me from. You can mention the teacher of your physics, Pierre Praye, because most of them are following later on these lessons. So I invite you, we continue together. Thank you. Reagan, Juliet, how are you?
Fine.
Fine. So let's proceed with our discussion today. There is a small part I want us to finalize, and that is the part on density. Tunatumali kidogo kumalizia density, lakini tutamalizia leo, then we start force. Yeah. So let's be there. Let's be very keen. Let's follow up and see where we stop. What did we say? Who can define for us density and give us the SI units of density? Now we're hoping you are alone, so you are the one to do it. Can you define this and give us the SI unit of density?
Density is mass per unit volume.
Yeah, mass per unit volume. So what's the SI unit of density?
Kilograms per meter cubed.
Yes, kilogram per meter cubic. How do we change the use of this from kilogram per meter cubic to grams per centimeter cubic and vice versa?
To change from grams per centimeter cubic to kilograms per meter cubic, we multiply it by 1,000.
Yes.
And it from kilograms per meter cubic to grams per centimeter cubic, we divide it by 1,000.
Nice. That is how it should be. Yes. So let me talk about density control. Let me discuss about density control for the next few minutes, then we shall proceed. We are going to play with about density control. Let me share the screen so that you can see it. So as you can see, what I want to draw, and this bottle is a container that looks like this. It looks like this. So it has it's just a small container with a neck and a stopper. So this part is the stopper. This part is the stopper. And down here, we have the neck. There is a part here which we are calling the neck. What is the role of a density control? What is the role of a density control? The density control is used to find the density of liquids and solids. We are going to explain how you can use a density control to get the density of liquids and solids. It's something that is very simple. Then we will discuss one example on how to get the density of a liquid or a solid using the density control. Yes. So now, first of all, before we see an example, there are things that we need to discuss on. One is the precautions when using a density control. Density control is so delicate when using it. Some of the examples or some of the precautions held by the neck, meaning you cannot just, if this was a density control, to make the liquid in that particular density bottle to expand. Yes. Number two, the outside of the bottle must be wiped dry carefully. Because we have to wipe actually outside the bottle, we have to wipe out dry and you do it carefully. Why must you have to wipe it dry? You have to wipe it dry because if you don't wipe the water outside the next bottle, it will be part of the mass that we are going to record. So it should be wiped out dry. Now, the other precaution is that there should be no air bubbles when the bottle is filled with the liquid. There should be no air bubbles when the bottle is filled. Create a margin or whatever the liquid, then you see some air bubbles. You need to shake it to ensure that the air bubbles are not there. Because if it has some air bubbles, then it will be very inaccurate. So it should be having no air bubbles for it to be very accurate. Remember what I said? It is used to make the density of both liquids and solids, not just liquids, but liquids and solids. After going to together, yes. So what's the next thing? I want to give an explanation using that particular example. Let me write this example on the board. I can wrap the word physics because you have already known that we are discussing physics. So the question is the mass of this bottle the mass of this bottle is 20 grams when empty. So even before we continue from there, that statement is very simple. It means that the mass of the density bottle was measured when it is having no liquid and it is 20 grams. That's the first statement. When full of water, it is 70 grams. So I put a comma. Then I write this 70.0 grams when full of water. After doing, what conclusion can you bring? 70 grams when full of water. But remember, it is 20 grams when empty. What is the mass of water that can fill the next bottle? The 70 minus 20. So the mass of water that fills the next bottle is 50 grams. Let's continue with the question. And let me use the word and 55.0 grams when full of liquid X. Yes, when full of liquid X. So here we have three things. When empty, when full of water, and when full of liquid X. When full of water, my point is 70 grams. When full of liquid X, my point is 12 grams. So it's very simple. One thing about that, mass of water. Okay, first of all, the question is calculate the density of the liquid X. Of the liquid X. Good. So let's move in step one. Mass of water. Mass of water is going to be 70 grams minus 20 grams. Why? It is 70 grams when full of water, meaning the mass of water plus the density bottle is 70. Then the mass of every density bottle is 20 grams. So we have 50 grams. That is the mass of water that can fill the density bottle. But something I want to say is that hii container nikijaza maji it is 1 liter. Yeah, hii bottle ni ya maji ya 1 liter. If I fill it with water, the water is 1 liter. If I fill it with another liquid that's water, maybe I fill it with kerosene, it will still be 1 liter. What will change is the mass because they have different densities. So if I fill this container with water, then with water, then I fill it with liquid X, the volume will remain the same. I don't know whether you're following me. on special conditions. Always, the first liquid that you are given to fill the next bottle is water. Why? Because the density of water is always 1 gram or not. Just know that the density of water is 1 gram per centimeter square. What does it mean? It means this. For every 1 gram of water, its volume is 1 centimeters cubic. If I have 10 grams of water, the volume is going to be 10 centimeters cubic. If I have 50 grams of water, the volume is going to be 50 centimeters cubic. Did you get it? Now, we have the mass of water that fills the next bottle as 50 grams. So, what is the volume of water that fills the next bottle? Taking into consideration that the density of water is 1 gram per centimeter cube. So, it's going to be 50 centimeters cubic. At that point, are you together? Boys and girls?
Yes.
Good. So the density bottle has a volume of 50 centimeters cubic as per this question. Now, let me ask another question. What will be the volume of liquid X that will fill the next bottle? Somebody tell me. You don't need calculation, you just measure it. Yes? Again? What is the volume of liquid X that will fill the next bottle? We have no. Pardon?
50 centimeters.
Yeah, it's going to be 50. I say, if I fill this container with water, 91 liters, if I change the liquid, I use another liquid. 50 centimeters cubic of water can fill the next bottle, then volume X is going to be 50 centimeters cubic. Common sense. If it can be filled by 50 centimeters of water, whatever the liquid out of the change, it will still be the same. Yes. Sabrine is watching me from Wajir. Thank you, Sabrine. When you come to school, anybody mwenye make a comment, akifika shule anakula kitu. So now, if you have the volume of liquid X to be 50, angalia hapa. When this bottle is filled with liquid X, its mass is 55 grams. But the mass of empty bottle is 20 grams. What is the mass of liquid X? Mass of liquid X. What is the mass of liquid X? Very simple. 55 minus 20, you get that 5 grams. Up that point, are we together? Where is my good friend Michelle Mukai? Up that point, are we together?
Yes.
Okay, sawa. Now, if we have the volume of liquid X and we have the mass of liquid X, can we get the density of liquid X? Is it possible?
Yes.
How? Density is given by mass over volume, which is going to be 35 over 50. by 10, by 5, 10, by 5, 7. We get 0.7 grams per centimeters cubic. Kuna mtu alikuwa amehisi mkono, niambie ulikuwa unasemaje? Good. Now, what's the question saying? Calculate the us what do we call it? It has not given us conditions in SI unit or not, but you can still convert it in the SI unit. How? By multiplying 1,000. So if you have any question, you can ask me on the chat box, or if you have any question, you can unmute and ask me as we are moving to the next question. Let's proceed. Kuna swali hapo. I hope you can see on the screen. I will write for the sake of those who are following me, for the sake of Sabrine. Sabrine, how are you doing? We have a question here. I will read on the beginning of the question. The question reads, in an experiment to determine the density of a certain solid B, the following readings were obtained using a density control. So the solid is solid B. The solid under question is called solid B. Now, kuna information tumepewa, and I want us to use the information very well. The first information is mass of density control, mass of empty density control. Mass of empty density control. Mass of empty density, aina kitu ndani 8 grams. Just what the person is doing to equate. Empty 8 grams. Now, number 2, mass of density control and solid B. Mass of density control, dB, and solid B. Sasa tumeweka solid B ndani ya density control ikatupatia 96 grams. Ikatupea gani? 96 grams. spend ngapi? 96 grams. So hapa hii 96 grams ingine ni ya solid D, ingine ni ya base total. Tuendelee. I want you to be very keen because kuna mahali hapo nataka ushikilie. Nasikia Reagan?
Yes.
Right. Number 3, mass of this bottle plus water and solid. Now let me now this way. Kuna wale watu mnapendanga kula, nimesahau jina yake, lakini there's some food unanunua kasupa, unaweka kwa kikombe na unaongeza maziwa ama chai, then you use a spoon to eat. I don't know what's the name. Ama good Weetabix. So just easy. Our Weetabix when you are growing, I don't know whether Nepali can understand what I'm saying. Ukipika ugali vizuri kwa sufuria, ukishaondoa ugali, si kuna ile inaitwa na ile inabaki ndani ya sufuria. Si mlikumbuka? Hiyo okay, tuachane nayo. Sasa hiyo sisi ndio tunatoa tunaweka kwa kikombe na unaweka chai na unakunywa. Now, let me use what Reagan has said. Ukichukua Weetabix na ujaze kikombe vizuri mpaka ijae. Mpaka ijae mpaka to. Ukimwaga chai ndani ya maziwa, bado itapata space ya kuingia. Sio kweli? Ukimwaga chai ama maziwa, see, it will still find its own space then. Exactly, that's what's happening right now in this question. Tumeanza hivi. Tumeanza tukaweka solid D. Tumeweka solid D ikaweigh 96 grams. Tukaongeza maji. Ikaweigh 132 grams. I don't know about let dry this. Mass of this bottle plus water and solid D. Plus water plus ama solid D or whatever, give us 102 grams. But kumbuka pale tu tumeambiwa the mass of empty this bottle ni 8 grams. Sawa sawa. Kwa swali yetu pale tumeambiwa the mass of water ni 30 grams. Now, solid D, what is the mass of solid D? Because ikiwa empty, this bottle ni 8 grams. Tukiweka solid D 96. 96 minus 8. Tumeambia 8 grams. 88. So hapa iko 88 grams. Can you confirm for me, somebody? If 8 plus 30 plus 88, what does it mean? Because kuna mahali hiyo swali imekosa. Ewe confirm sasa ndio Reagan. Can you add 48 plus 30 plus 88? Better
126.
126. Kuna mahali imekosea. Commit kupea mass of water. Sema 30 grams. But from our second statement down there, mass of this bottle plus water ni ngapi? Mass of this bottle plus water. Imeambiwa ni 88 grams. Can you get the mass of water? Because the mass of solid D, ukitaka mass of solid D, unasema 96 minus 8, unapata 88 grams. Now, ukitaka the mass of water, kumbuka umeambiwa mass of this bottle plus water ni 88 grams. Now, ukitaka the mass of water, itakuwa gani? 88 minus 8, unapata hiyo gani? 80 grams. This is the mass for water. Kuna mahali tu imechanganya kidogo, lakini usijali. Swali, I think I did not correct the question very well, but no problem. Now, in all this, we're supposed to calculate the density. We're supposed to calculate the density of solid B. And for us to calculate the density of solid B, we need its mass, whereby we already have the mass 88 grams. And now we want to get the volume of this particular solid B. Now, so in order to use it, if this bottle, which is of mass 8 grams, was filled with solid B, it can be like a 96 grams. So the mass of solid B is about 8 grams. How can we get the volume of this particular density bottle? We shall find the volume of the density bottle, then we shall be okay. Now, hapa kuna mass of density bottle, water and B ni 1 grams. Is it possible we get the volume of water? Is it possible we get the volume of water? Because the volume of water that fills this particular density bottle. Kama tuko na mass of water that fills the density bottle, kama 80 grams. Now, in order to get this, hapa kuna mahali wali ni 8 na yote inafaa ikuje 1. Hebu nifanyia kwa hii nikisema 1 minus 88 plus 8 tuone inatuletea ngapi. 1 minus
96.
Madama?
96.
Okay. So the mass of water is 36 grams. So it means we are going to know this one in Ghana was one immediately go. So hii ingine tuachane nayo kwanza. So it's 36 grams. Let's use that information so that now we can get the volume of the density bottle. Now, tell me now here, because we are supposed to get the volume of the density bottle, and then in that volume of the density bottle, we remove the volume of water, because the volume of water, if the mass of water is 36 grams, automatically it is going to be 36 centimeters cubic. So the first question that we are being asked here is this. From the information we have. The first question is mass of water. The question has already given us the wrong thing, because it is what the information by the mass of water come at 80 grams, at the same time, if the mass of water come at 6 grams. So if you work with what it has given us over there, it's going to be 0.08. So I work now. This one here will be work now 80 grams of water, which is I may find the kilogram, 0.080 kilogram. Then the volume of water, of course, when you are the mass of water, you can easily get the volume of water. It is the same. Come on, 80 grams, then the volume is going to be 80 centimeters cubic, or you can convert it into meters cubic. Then the volume of the density bottle. Let's use the former information. Density bottle alone and water is 88 grams. So meaning, tukiondoa 8 grams ya density bottle, then 80 grams is the volume of water that fills the density bottle, which is also the volume of the density bottle. So the density bottle, I think I used a lot of values here, but no problem. The volume of the density bottle is 80 centimeters cubic. Now, mass of solid B, to examine the 88 grams, then the density of solid B is its mass, which is 88. Its mass, which is 88, divided by the volume. Its volume. So, kama tumepata kwamba the volume of the density bottle is 80 centimeters cubic, to know the volume of water, which is 36. 80 minus 36 again. Just do for me, I will do 80 minus 36. So it is 18 divided by 44, and you'll get as 2. Ignore my working is here because it did not work. But I'm going to correct that question after this. So let's do this one question again. And I will know a baby. Let's write that on the board. Are they total? Can you be doing that question so that we do it together? For those when you're watching online, after reading the question, you can pause the video, then you do the podcast. So it is this way. A dense total has a mass of 17 grams on hand. A dense total has a mass of 17.5 grams when empty. When full of water, its mass is at 0 grams. So dense total plus water, it will give us that 7.5 grams. When full of liquid X, its mass is at 12 grams. So dense total plus liquid X is contained at 5 grams. I'm at 5.0 grams. Then, of course, if the density of water is 1 gram per centimeter cubic, calculate the density of liquid X. Calculate the density of liquid X. Just 1 minute, please wait first. Mark and knife. Look funny to begin. Pada macam-macam masih ada poin itu dan baik. If that is the true answer, mungkin awak kamera kan? Sabri, where have you gone? Yes, so let me do this question very fast. You are being asked about the density of liquid X. So the mass of empty dense total is 3.5 grams. Dense total plus water plus 7.5 grams. So mass of water is over grams. Mass of water is going to be minus 17.5, okay? Reckon that 7.5 minus 17.5. Yes?
17.5.
Oh, this is 17? Yeah, it's going to be minus 17.5. Go back one. That's what we it is 20 grams. Now, so E mass of water is 20 grams, which is also the volume of water that fills the dense bottle, which is also the volume of the dense bottle, which is also the volume of liquid X. So, in summary, volume of liquid X, volume of X is called centimeters cubic. What about mass of liquid X? Mass of liquid X is going to be mass of liquid X. That 5 minus 17.5. Everybody else doesn't again. That 5 minus 17.5. Now in back, snack calculator.
17.5.
17.5. Grams. Kama kawaida, if you want to calculate density, density is given by mass over volume. So mass is going to be 17.5 divided by volume, which is 20. Kumbuka ni grams, centimeters cubed. Now, take your calculator, especially those who have them. Can you say 17.5 divided by 20? Yes, Stephanie? 0.875. 0.875 grams per centimeter cubed. 36. Yes, any question? Next time we got 87.5. Can you work on your calculation? Zuri na Nasri? We can go from there. Nani wako na swali? Are you satisfied, Regan?
Yes.
Michelle? Definitely, of course, you have the answer. That's okay. Now, let me handle another concept, the density of mixtures. The density of mixtures. Density of mixtures. Density of mixtures. Let me explain this. Have you ever heard the meaning of the word alloy? Maisikia maana ya alloy? Alloy.
It's a mixture of metals.
Yeah, when two metals are mixed together, for example, brass is an alloy of copper, tin substances with different densities. Like you mix 800 kilogram of meters cubic kama 0.8 grams per centimeter cubic. You're going to come up with a mixture that has a different density from the density of the two substances making up that particular mixture. In most cases, the density is in between the densities of those two. Don't make a blunder of getting the average density to be very low. We don't get the average. Average will be low unless the masses and the volumes used are equal, or simply the masses. But still, the best way is apply this formula. Density of a mixture is called scope. Total mass over total volume total mass over total volume. Hapo tuko pamoja. Total mass of the mixture over the total volume. If you are given a mixture of water and ethanol, or water and whatever the two mixtures, get the mass of each one of them and the volume of each one of them. Then you will easily apply that formula. There's an example here. I will read for the sake of those who are online. Let me read the question very fast. The question is, a mixture contains or consists of 1 centimeters cubic of water and 60 centimeters cubic of liquid X. A mixture consists of, so here we have water, then we have liquid X. You know, we naambianga watu kwanza andika water kando, andika liquid X kando. It will be very simple for you. You will see how we will do it right now. So the question is, a mixture consists of 40 centimeters cubic of water and 60 centimeters cubic of liquid X. If the densities of water and liquid X are 1.0 grams per centimeters cubic and 0.8 grams per centimeters cubic respectively, meaning water has a density of 1, liquid X has a density of 0.8. Calculate the density of the mixture. Calculate the density of the mixture. So, upper, andika density, andika mass, then andika volume. The same to this other one. Density, mass, then volume. So from the question, the density of water is 1.0 grams per centimeters cubic. From the question, this is 0.8 grams per centimeters cubic. What else are we doing from the question? The volumes. Water. Hii ingine volume yake ni 60 centimeters cubic. Now, from the information we have, let's get the mass of each of them. The mass of water is going to be 1 gram. Sorry, it's going to be 40 grams. Why? Because the density is 1 gram per centimeter cubic. What is the mass of liquid X? If density is given by mass over volume, so mass is going to be volume times density. So 6 times 0.8. Uniambia ni ngapi? 6 times 0.8. Tupate mass ya X. Uniambia 6 times 0.8. Yes, Beverly. Ni kama nakataa 60 times 0.8. First of all, it should be less than 60 because we are multiplying 60 with a number less than 1. Reagan?
48.
Yeah, it will be 48. 48 grams. I don't know what my friend Bafana means. Method correction. So, density of a mixture is equal to total mass, which is 40 plus 48, over total volume, which is 40 plus 60. Once the 40 plus 48, you give me 88 grams. Divided by 100 centimeters cubic. I'll go port by you then you will have a even than my 0.88 grams per centimeters cubic. Apa tugas pamannya? Mana aku nak balik? Nanya aku nak balik berdeli. We can proceed. Akan wape swali ingine. Let me read this question for those who are online. The question reads: a solution contains 40 centimeters cubic by volume of alcohol and 60 centimeters cubic by volume of water. If the density of the alcohol is 0.79 grams per centimeters cubic and the density of water is 1.0 grams per centimeters cubic, calculate the density of your solution. So you have their volumes, 40 and 60 of alcohol and water respectively, and the density is 0.79 and 1 respectively. Calculate the density of the solution. You expect it to come because the previous questions we've done was on the same. So make sure your answer is 0.916. Yeah. So I want to discuss something next about time, how to make time. So what is time? I'm not asking what is the time, I'm asking what is time. Ndaka tuanzie hapo. Can you say that a time is the measure of duration and the SI unit is seconds? That is the meaning of the time. And this second, has other units which we can use it. like minutes, hours, milliseconds, microseconds, all through EPC. Now, 1 minute is always 60 seconds. You wake up to 1 minute in 60 seconds. I'm going to Java the 1 minute. One minute, 60 seconds. Don't write SEC, and in full seconds. 1 hour, how many seconds? 1 hour, the 60 minutes, which is that 600 seconds. That's 600 seconds. 1 day. 1 day. One day equal to 24 hours, which is 8,400 seconds. Which is 8,400 seconds. 1 second. So that to be 1 second is equals to 100. And second moja is 100 second. Hii 1 second ni kidogo. Ukikawa ndani inakupea 100 second. Alafu hiyo 1 second is 1 million. Sasa nataka ujiulize ni nini hiyo unaweza divide 1 second in 1 million microsecond. Microsecond. The symbol for micro is you write something like 10x microsecond. You understand like I was doing. I was telling some people somewhere how time flies. Look here, let me explain something. That nielezee uone penye. This is all, in fact, apart from this, tuko na months. Kwanza tuko na weeks. Tuko na years and centuries. Let me give you a second is important. 1 second is important, but not to a farmer. Not to somebody who wants to invest. For example, one day there's someone, a friend of mine, alikuwa amebakisha 2 years to retire. And these 2 years to retire, this guy had not invested in anything. He had not been married. I mean, everything was off. So we mtu hata ukimbia 1 year, haitamsaidia. Hii 1 year ni kidogo sana. Ya tatizo amarusha gedoa 30 years. Hiyo haimsaidii. Hizo 1 year ni kidogo sana kwa mtu kama huyo. A student, a candidate mwenye sasa hivi anafanya mtihani. For them now, ukimwambia 1 hour to exam, huyu mtu mwenye ako amefanya ile investment, alikuwa tukaza ile investment, ukipea 3 days haitamsaidia. You see how 3 days is important to a student. Mwanafunzi imekaribia mwezi mmoja, atakwambia nipe 2 months and cover the syllabus. 2 months itamsaidia, lakini 3 days haitamsaidia. Lakini mwenye shaka kwa syllabus anangoja tu revise even a day enough. Now look here. Athletes who are running a short race. Si mnajua short races kina Omanyala, kina Tepogo wa Botswana, kuna huyu wa USA anaitwa nani? Mtu akikumbuka ataniambia, the sprinter from USA mwenye anakimbia mbio sana. We have the retired general Simuniambia mtapata kimya kama kupita zamani. Amtaniambia from Jamaica. Aya. For them, 1 second was so important because mostly akona 9.65. Yani difference ni kidogo. So if you think 1 second is not important, ulita watu wa sprint, those who are running. Aya. Alafu sasa kuna wale wa long races kina Kipchoge na wengine. Unasikia mtu amemaliza marathon na 2 hours 6 minutes. Win number 1. Number 2 is 2 hours 7 minutes. 2 hours 10 minutes. So these people, minutes is very important to them. So time can vary depending on how it is. So do you know how to convert time? Now let's get to this very important thing. How do we measure time? How do we measure time? Reagan, I will go, man. We'll see what out to Germany.
We can measure time using a stopwatch.
We can measure time using a stopwatch or
a stop clock.
A stop clock. But at what point do we require a stopwatch? When accuracy. Are you together?
Yes.
When we need. Lakini kwa klasi yenu pale mbele mnakuanga na stop clock imewekwa pale. Na kuna wengine they will take 1 minute kuona nzanga anaangalia the short hand clock iko wapi, angalia the long one, angalia by the time ana realize 12:30 anakuwa ameendeseka sana kwa hii dunia. So ukiona klasi yenu haina stop clock, venye walimu waliwaona wakaona nyinyi hamjui kusoma stop clock, wakaachana nayo wakapeleka kwa klasi zingine. Watu wanakimbia race ya 10 seconds. You cannot use stop clock. By the time, in fact, they will finish before it moves. So accuracy, if a lot of accuracy is required, you work with a stopwatch. Stopwatch you need to work in here. Are you together? We prefer stopwatch because it is very accurate and it is easy to use and even to handle. It is easy to read stopwatch than stop clock. Tuendelea bado. What is the reading on the time shown on the stop clock? Let me know the book. Imeandika 10:22:4. 10:34. Yaani umepimia watu wakimbie. To record the time as an engineer tuambie what was that? Mtu amekimbia 10 hours, 10 days. I don't know with the Ghana, but the first ones is then said seconds. Here, kwanza inapanga minutes, seconds, then said seconds. So we don't record time in minutes. We don't record time in minutes. So kitu kwanza, convert for us this minute plus 22 seconds plus 34 seconds convert 4. So it's going to be 6:22. Haya. Sasa nataka tufanye question 5, 4, 5, 6. Then to proceed na kitu kingine. But before that, kiandika hivi 0006 what will you record as time? Are you seeing what I'm doing on the board? Bevan, are you seeing it? You cannot see what I'm doing on the board. Michelle, can you see? Okay, now what time will you record? Screen ya stopwatch ikiandika hivyo. You'll have to write 6.14. How? 0 minutes, 6 seconds, and 14 seconds. So convert this into minutes to 0.14. So it was 6.14 seconds. So instead I'm saying this, stopwatch, you have to give the readings to 2 decimal places. Ukibeana this, okay, look here. Let me use this as an example. The same, but I'm making I know you will be tempted to say it's 6.16. Technically you are right and you're wrong. It should be up to a good decimal place, so it's going to be 6.10. It is going to be wrong. Did you hear me, Michelle? Nice. Now we can proceed with question that I have displayed on the board. Let me read to my people or my followers in YouTube. Define density per tolerance if it's SI unit. That's the first question. Define density per tolerance. Sorry. Define the term density and if it's SI unit. Number 2. A grade shows a liquid level as 20 centimeters cubic. Grade. Imeandika kama 20 centimeters cubic. 10 drops of the same liquid, 10 drops of the same liquid, each of volume 0.5, are added. Calculate the new liquid level. Liquid 20. Tukaongeza how many drops? Tukaongeza 10 drops, and each drop is 0.5. What will be the new reading in that particular period? Okay, define this technique as I need one of you to do it. Atiamujui. Namna za maji. Wewe chakula. Rega ndio zamani na ulikuwa umetoka class kwanza.
My network had gone down.
Oh, okay.
Density is mass per unit volume, and its SI unit is kilograms per meter cube.
Yeah, mass per unit. SI is kilogram per meter cubic. That's 20 centimeters cubic. 10 drops of the same liquid, each of volume 0.5 centimeters cubic, are added. Calculate the new liquid level. Regan, unasemaje?
15 centimeters cube.
15 centimeters cubic. Let's see. Let's see. Now, you ready? When full, it is reading 0. Sasa hii yetu, the volume tumeambiwa iko 20. Somewhere here. So the more when you remove some drops, the volume of the liquid decreases, but the readings increases because itakuwa in the reading decreases. Like in our case, 25. So in short, we added 5 centimeters cubic. So this 5, ukiongezea 5 of the liquid, lakini the readings will decrease, so it's going to be 15.0 centimeters cubic. That was very correct for you, Reagan. Jerikaya kwanza ndio wenye wataandika waangalie nini inaandikwa. Haijafungwa? Imefungwa? Haijafungwa? Sawa sawa, I think now we can proceed. Kuna swali hapo inasema an empty density bottle has a mass of 15 grams. When full of alcohol of density 0.8 grams, its mass is 47 grams. I think this question is good. I want us to analyze. Let me just a minute. I'm checking on something and I'll to calculate. So tunataka angalia hapa. I can write the question first. Sleep. An empty density bottle. So nikiandika tu hivi empty density bottle. Hiyo ni gapi? Tumeambiwa ni gapi? As a mass of 15 grams. Hiyo ni density bottle yenye aina ya kitu gani? When full of alcohol, its mass is 47 grams. So this nikiandika DP plus alcohol, that is when full of alcohol, its mass becomes 47 grams. So, now, what's the mass of alcohol? Do I think I have a mass of alcohol? Mass of alcohol, it's going to be 47 minus 15. 47 minus 15, 32 grams. 32 grams is the mass of alcohol. From our question, we are told that the density of alcohol is 0.8. 0.8 what? Grams per centimeter cube. Grams per centimeter cubic. Kumbuka tunasemanga density is given by mass over volume. So for us to get the volume of the alcohol, volume is given by mass over density, which is going to be mass, which is 32 over density, which is 0.8. So from that calculation, what will be the answer? Oh, the go below. I see it here. Okay. That's two divided by 0.8. Remember that. Kamu jawab. Hiyo ni swali kwenda kusumbua. Michelle, imekusumbua? Ujui? You can imagine watu wakijua ujui that 2 divided by 0.8. Ondoa hii decimal kwanza, waje kae Pascal. 2 divided by 8 ni 4. Hiyo decimal place ya chini ipeleke ipo kama times 10. Hii ni mwanzo mchezo kwa 40 centimeters cubic. Now this 40 is the volume of the alcohol that fills the density bottle. So it is also the volume of the density bottle. Volume of the density bottle. Hapo tuko sawa. Yeah, so let's see the actual question. calculate the full of water. Sasa, calculate the mass when full of water. Let me add somebody to class first. Yeah, okay. The mass when full of water. So now, if the volume of this bottle, now is 40 centimeters cubed, when you fill it with water, the mass of water will be 40 grams. Plus now, the density bottle is 15 grams. It gives us 55 grams. Nice. Thank you, Nasra, for giving me that correct answer. Now, its mass, when full of mercury of density 13.6 grams. What will be the mass of the density bottle? Kumbuka, the mass of the empty density bottle is 15 grams. Now, tunataka hii kwa 15 grams tuongezee mercury, just a bit kidogo. Tuongezee mercury with a density of 13.6 grams per centimeter cubed. Kumbuka, what will be the volume of mercury? The same volume of alcohol and water, which is 40 centimeters cubed. And if density is given by mass of a volume, the mass will be given by volume times density, which is 40 times 13.6. Then you add 15 plus 15 grams. You get grams. 40 times 13.6. Let me.
$544.
544. Okay, multiply this times this. 544.
Yes.
Can you add now 15?
559.
Good. 559. Let me write 559 grams. Thank you. Nataka tuanze 14 turudi hivi. So let me read question 14. Then I change something. I give you 2 minutes. Well, in fact, you can start working on question 14. A mixture is made up of two metals, X and Y. We have a mixture here which is made up of X and Y. The mass of the mixture is 30 grams. That's a upper nataka. In fact, let me write this question slowly because a mixture is made up of two metals. Of two metals, X and Y. Supreme, you can tell me whether you can do it and write on the board. the mass of the mixture is 30 grams. It's 30 grams, and the volume of the mixture and the volume of the mixture is 4.5. Is 4.5 centimeters cubic. Determine, make a full swallow above. Determine the mass of the metal X in the mixture. Alafu hapa kuna information imeandikwa density of metal X is equal to 600. 6,000, that is kilogram per meter cube. Now Y is equal to 7,900. 7,900 kilogram per meter cube. The question is determine the mass of the metal X in the mixture. That's our question. Wacha ni focus vizuri. Sabrina amesema oni, wacha ni focus vizuri. What about now, Sabrina? Ama wacha kwanza nifanye hivi. Sabrina, I'm sure haionekani sahihi, right? Ama imeonekana? Is it visible, Sabrina? Hebu niandikie hapo kama inaonekana ama haionekani. The rest, keep doing the question. let me read for you the question. I think now, Sabrina, you can see. Why said you were okay? You wanted to see. So I can proceed and do the question right now. Can you see it now, Sabrina? Yes. I done Beverly and Reagan and Michelle Mungai. That's what is why. Uko na answer Reagan?
No.
Umejaribu kufanya?
Yes.
Umejaribu kufanya Beverly?
Yes.
Uko na answer?
No.
Michelle, umejaribu kufanya? Uko na answer? So the tune is yes, umejaribu kufanya, lakini answer kufanya ni sawa, lakini hapo kwanza kidogo nani, but nani Nasra, I can see mimi naangalia screen nasa. Beverly, uingia YouTube uone kama iko visible. Beverly, in 1 minute then come back. In fact, hata usitoke kwa lesson, just check that from your side, because mimi naona ikiwa sawa watu wa YouTube wanalalamika na naona hiyo. Nasikia Beverly? Even Michelle, just check on my YouTube on how clear that statement is. Sabrina, let me read for you. A mixture is made up of two metals, X and Y. The mass of the mixture is 30 grams, and the volume of the mixture is 4.5 centimeters cubic. Determine the mass of the metal X in the mixture. Good. Now, let me answer the question. Beverly, make a comment pale kwa YouTube nione kama iko clear ama iko clear. Somehow clear. Okay, I think I can proceed because okay, so two of you have told me you can watch from that side again. Okay, now let me work on this question now. Let me do this. A mixture is made up of two metals, X and Y. The mass of the mixture is 30 grams. Sasa, I want us to do this. I want us to say X plus Y to be equal to 30 grams. What have I done here? Nimefanya nini hapo? I've taken X and Y to be the masses. So is this X grams plus Y grams to give us 30 grams? That is equation 1. Can you label this as equation 1? The volume is 4.5. The total volume yao ni 4.5. Hapo kama tuandika simulajuanga density is given by mass over the volume. Volume is given by mass over density. So for x which has x grams and for y which has y grams, it's very simple. The volume of x is going to be the mass of x, which is x, over the density of x. The density of x is 6,000 kilograms per meter squared. Because I've given the mass in grams, I will also give the density in grams per centimeters cubic, which is going to be 6,000. Okay, it's going to be 6 grams per centimeters cubic. So, but I will remove these things, grams and fewer. It's just going to be x over the density, which is x over 6 plus e here is going to be y over what was for me 7,900 kilograms per meters cubic into grams per centimeters cubic. It's going to be 7.9 over 7.9 is going to be 4.5 centimeters cubic, equation 2. Ukishafika hapo, you are almost done with the equation by the way. Kila mtu amefika hapo? Good. Now, okay. Hii nimesahau ni iko topikadi ya maths. I don't know kama iko form 1 ama form 2. Solving by elimination and substitution method. You go for? Good. Now, it will be back in the next 1 minute by the way we're supposed to be done with this. What I can always say is 3 grams inafanya there. So x plus y is equal to 30. X over 6 plus y over 7.9. I want us to make x the subject of the formula. And to that Java, I can use here. So if x plus y is equal to 30, am I correct to say x is equal to 30 minus y? Guys and boys, if x plus y is equal to 30, is it correct to say x is equal to 30 minus y? Yes. So if x is equal to 30 minus y, nataka hii nimetoa kwa the first equation. Now I want us to transfer this to the next equation. Anywhere we have x, weka 30 minus y. Kidogo tu. Y is equal to anywhere to corner x where 30 minus y. So it's going to be x over 6. It's going to be 30 minus y over 6 plus y over 7.9 to be equal to 4.5. Sawa. Nataka to multiply LCM ya 7.9 na 6 ni ngapi? I will just take the multiplication. I will just do this.
47.4.
47.4. Madam ngapi? 47.4. Good. Now multiply na 47.4 kila mahali times 47.4 times 47.4 times 47.4. What are you going to have? Nataka to transfer pale. Sinaweza kufuta huku juu kama umekuwa swali, sio? Reckon, sinaweza fika kuuser up here.
Yes.
Mwenye atakopi swali sasa sura now so we have 30 minus y into bracket 47.4 over 6. No. So can you cancel for me this 7.9, right? Am I the one? 7.9 plus by this one by this 6 plus 6y is equals to, do for me 4.5 times 47.4. Let me do it.
$213.3.
It's equals to 213.3. Thank you. Now, open for me this bracket. 30 times 7.9. Najua itakuwa minus 7.9y. So 30 times 7.9 ni ngapi? Niandike ngapi hapa?
237.
Hapo na decimal okay, sawa. 237 minus this plus 6y is equals to 213.3. I want us to get the value of y. Do for me this. Nataka uchukue hii na uchukue hii sote siende huku. Then take 213 ikute hii side. It's going to be a minus. So 237, do for me this record. 237 minus 213.3 is equals to 7.9 minus 6y. Nipe 237 minus 213.3. I hope so. 23.7. 23.7. Na hapa ni ngapi? 7.9 minus 6 ni ngapi? Ni 1.9.
Yes.
Now, what's the value of y now? Y is equals to 23.7 divided by 1.9. I hope you can calculate that. I'm a better than to 23.7 divided by 1.9. Y ni ngapi?
12.47.
12.47. Now, tushapata value ya y. Peleka hapa. Sema x plus 12.47 is equals to 30. X plus 12.47 is equals to 30. Now, x is going to be x plus 12.47 is equals to 30. X is equals to 30 minus 12.47. Ukapata ngapi?
17.53.
17.53. That is what we were supposed to be looking for. Swali imeuliza determine the mass of metal X, 17.53 grams. Sema iko sawa?
Yes.
Okay, thank you. Nataka tuende kwenye 13. Question 9. Nataka sorry. 29 kwanza. A butcher has a big balance. I will clear the board so that I can write another question. A butcher. Can you comment on the YouTube kama inaonekana tunaandika a butcher has a big balance? B balance. and masses. Just drop a comment and masses 0.5 kilogram and 2 kilogram. Swali ni gani? How would he measure? How would he measure? How would he measure 1.5 kilogram of meat on the balance at once? Of meat on the balance at once. Let me see, come up. Inaonekana? I want to see what the... Yes, Reagan?
And he places the 2 kilogram one on one side. Then on the side where the meat is placed, he also places the one with 0.5. Then it should be measured, since the 0.5 is on the side of the meat, it should have removed from the 2 kilograms, making it 1.5 kilograms.
Okay. Somebody another could explain. Sioni from my side. Just check if this imeandika is feasible. So I'm saying a butcher has a B balance and masses 0.5 kilogram and 2 kilogram. How would he measure 1.5 kg of meat on the balance at once? Let me explain that concept as I'm waiting for you to become eco-feasible. Eco-feasible. Okay. Sawa. P-balance kinagana hivi. So hii tu ni mahali unaweza wekelea whatever you want to measure. But so this person has a mass of 0.5 kg. Hizo basi zinakaanga hivi blocks hivi. Na ingine ni amesema ingine ni 1.5, na ingine ni 2 kilogram. Hii 1.5, hii ni 2 kilogram. Anataka kupima how would he measure 1.5 kilogram of meat on the balance at once. Fanya tu reka amesema atachukua mass. Let me remove this box. Atachukua mass ya 2 kilogram aweke hapa. Hii ya 2 kilogram. Akishaweka hapo, of course, akichukua tayari mass ya 0.5 aweke hapa, it will not balance. Itakaa hivi. But akiwekelea nyama, you know now the difference between 2 and 0.5 is 1.5. So ile nyama ita balance 2 kilogram. Akiongeza 0.5 kilogram mass, it will be what you wanted to measure. Are you together? Is all umeelewa? Okay. Now, tell me what of this one in make sense. Yeah, we show. It's only 3 minutes to the time. Aye. Good. Tunafanya question 10. It's our last question for today. Can you try putting them as I'm writing it on the board for those who are watching me? Let me make the question. The mass of an empty density bottle is 25 grams. Let me share it by the oh, you get a can in the book. I don't like this pen. I don't like this the most. That one. You just the pen. Chamusho. Let me use this. The mass of an empty density bottle. Empty density bottle. How much? 25 grams. When full of water, Ligabi, 50 grams. Sawa? And when filled with formalin, density bottle plus formalin is whatever 60 grams. Formalin is certainly produced in hospital. Calculate the mass of water. Sasa, when full of water is 50, when empty is 25, so mass of water. So this is going to be 25 grams. The other question is volume of water. So density is going to be 25 centimeters. Why? Mwambie wanipe 5 minutes to myself. So volume of water is going to be the same as the mass of water because the density is the same thing. Then volume of the density will be the same as the volume of water. So why don't you think about So I get a mass of formalin. This total plus formalin is 60. With this total is 25. So 60 minus 25 negative. That's 5. So mass of formalin. That's 5 grams. Volume of formalin is our volume of water because if 25 should be in a field, then formalin getting 25. So density of formalin is going to be the mass of formalin, which is that 5 divided by 25. Use your calculator, you will get it in grams per centimeter squared. Umefanya swali? Try again. You want clear?
Yes.
Okay, sawa. So nataka tuachie hapo leo. Tomorrow we will be doing, tutakuwa tukifinalize chemistry classification of substances, simple classification, and but tomorrow we are doing GCSE practicals. I may be in school, but I will communicate in the group. Yes. Have a nice evening, everyone.